Okay, so this is section 2.1, graphing integers on a number line. Okay, so the first definition there is number line. So if we look at number line in the book on page 52, basically what it is it shows the order of numbers. Okay, so we'd want to write shows the order of numbers. Okay, now what a number line looks like is it's just a line with arrows on both ends, and then you've got a bunch of tick marks that are equally spaced apart, and those tick marks are labeled by numbers. So maybe we've got like a -1, a 0, a 1, and a 2. Okay, so numbers on the right side are higher numbers, and numbers on the left side are smaller numbers. Okay. Next thing we've got here is negative numbers. So what negative numbers are numbers that are less than 0. Okay, so negative numbers, I'm sure you've heard of before, are numbers that are less than 0. Next thing here is a Venn diagram. So what a Venn diagram looks like is we've got two circles or two groups, and typically they're interlocking like this. Now they don't have to be, because this one down here is also a Venn diagram, but typically when you see Venn diagrams you see two interlocking circles like this. What those mean, so say we were talking about a group of people that is on the football team and a group of people that are on the basketball team. So if we have one circle for the football team and one circle for the basketball team, this section here, so right in there, would be the section that's just on the football team. Okay, this section here, so this circle right there, would be people that are just on the basketball team. Now this cross part, where those two circles cross each other, those are people that are both on the football team and the basketball team. Okay, now you're probably wondering why I drew this box around it. What this box means is it's basically everyone else who's not in either of those groups. So say you're not on the football team or the basketball team, you would be in this outside box here. Okay, that's what the outside box stands for. So only football teams in this one, both is in the middle, only basketball teams there, and then if you're not in either of those, football or basketball, you would be in that outside square. Okay, so that's one example of a Venn diagram. Sometimes you'll see Venn diagrams that are kind of like this one here, where you've got a circle and then another circle there. Sometimes you'll have them, and this one's probably the least likely one, but like a circle and then another circle there that's outside of it, so nothing would cross over there. And this one, everything in this group would cross over into both groups. But the main one that you see is probably something like that. Next thing here is integers. So what integers are they are all of the numbers that you would typically count, so like 1, 2, 3, 4, 5, 6, no decimals, no fractions. You also have 0 in the group of integers, and then you also have the negative version of those numbers, so -1, -2, -3, and so on. So you wouldn't have any decimals or any fractions, just your regular numbers that would go up, 0, and then your negative version of the regular numbers. Next group we have here is natural numbers. Natural numbers, or sometimes they call them counting numbers, are basically the numbers if you were going to count something. So like if I was going to count how many letters are in this here, I would start with 1, 2, 3, 4, 5, and keep going. Okay, you don't start with 0 when you do the natural numbers. Okay, it's just the counting numbers. So if you were going to count something, you start with 1 and then you go up. Next group there is whole numbers. So for whole numbers, it's basically all of those natural numbers plus a 0. Okay, so the only difference between natural numbers and whole numbers is we add 0 in there. Okay, so what we're going to do is we're just going to give some examples of these inside the Venn diagrams. So we're going to start with natural numbers. So examples of natural numbers would maybe be like 3, 15, 2, 1, something like that. So a number that you would, if you were counting something, you could count to. Okay, so that's the innermost, most specific group there. Okay, The next most specific group is whole numbers. So this whole number circle also includes all of these natural numbers, right? Because the whole natural number circle is inside the whole number circle, but the only difference between whole numbers and natural numbers is 0. Okay, so the only one that would be in this outer circle for whole numbers that wouldn't be in this inside circle for natural numbers is 0. Okay, now when we jump to the integers group, the only thing that would be in the integers group that's not a whole number and not a natural number would be our negative versions of the numbers. So like if you had -3, -5, -7, -20, anything like that. So those would be classified as integers. So everything that's a natural number is in this one. Everything that's a whole number is in the natural numbers and then plus 0. Everything that's in the integers is all of these negative ones here, all of the whole numbers, and all of the natural numbers. So integers is the broadest category there. Okay, next definition we've got is graph, and what they have for definition of graph is plotting coordinate points. So graph is where we plotting coordinate points. Okay, and then the next one there is coordinate. So coordinate is the number that corresponds to a point. So coordinate, the number that corresponds to a point. Okay? Okay, the next thing they want us to do here for example 1 is they want us to go through and figure out which coordinates or which numbers go with the points that they ask us for. So it says name the coordinates for T, D, and B. Okay, so let's look at T first. So if we look at our number line here, we've got 0 in the middle, got a -5 there, -10, +5, +10. So our middle ones here aren't numbered, but if we look here, looks like there's 1, 2, 3, 4, 5 spaces between 0 and -5. So each one of those little tick marks must stand for one unit. Okay, so if we're looking at T, and T is 1 unit to the right of -10, well, 1 unit to the right would be a little bit greater than -10, so T would be at -9. Okay. Next one there is D. So if we find D, D is 1 unit to the right of 5. So 1 unit to the right of 5, 1 more than 5 would be 6. And then B looks like it's 2 units to the left of 0. So if we go 1 unit, that's -1. 2 units would be at -2. So B is at -2. Okay, next thing here. Okay, so for our next one, they want us to graph these, the points K, L, M on a number line. K has a coordinate of -4, L has a coordinate of 2, and M has a coordinate of -1. Okay, so the first thing we need to do is we've got a line here, and we've got to make our tick marks. Typically I put 0 in the middle, and I usually count by ones because these are pretty small numbers here. So I'm going to go 1, 2, 3, 4, I'll go up to 5 here, that should be big enough, and I'm going to do the same thing in the negative direction. So -1, -2, -3, -4, -5. And you want to, when you're making a number line like that, you want to try to space out the tick marks as evenly as possible. Okay, so then the next thing we do is we graph these. So first one we've got is K with a coordinate of -4. So we're going to go to -4, and then on the line, we're going to stick a point. We're going to label that K. Next one there, we've got L has a coordinate of 2. So we're going to go to 2 on the number line, which is 2 spaces right of 0. Stick a point, and we're going to label that one L. And then M has a coordinate of -1. So 1 left of 0 would be -1. Stick a point. Label that one M. Okay? Simple as that. Okay, so the next thing here is going to be trying some on your own. So on page 53, I want you to try out A and B on your own and see how you do. Okay, so A, to check that one out, for A, they got -2, 0, and 5 for their answers. And then for B, they've got a number line there, something like that. Looks like they've got -5, -4, -3, -2, -1, 0, 1. Okay, so they've got a point K at -4, a point M at -1, and a point P at +1. Oops, that one's supposed to be M. Oh shoot, this first one here is supposed to be N. N, M, and P is at 1 there. Okay, something like that. Okay, so next thing here. So for two numbers on a number line, the one to the right is always greater. Okay, and we talked about that a little bit before. Bigger numbers are on the right, smaller numbers are on the left. Okay, so the next thing here is they want us to make the sentence true using a greater than sign or a less than sign. Okay, so with these, you always want to eat towards the bigger one. Okay, so if I'm looking at 3 and -4, I like to think about these as like money. So what's better, having $3 or owing someone $4? Well, it's probably better to have money, right? So we're going to eat towards the positive number in this case. Okay? And positive numbers will always be bigger than negative numbers. Now here, with this next one for B, we've got -1 and -3. Okay, so thinking back to money again, if I think about owing someone, is it better to owe somebody $1 or owe somebody $3? Well, it's probably better to owe somebody just $1 than $3, so I'm going to be eating towards the dollar in that case. Okay? Alright, so you guys look at on page 54, try out C through E, and then check back in and I will give you the answer to those. Okay, so for C, they got greater than. For D, they also got greater than. And then for E, they got less than. Okay? Okay, next thing here, example 4, they want us to order these temperatures from least to greatest. Okay, so one thing we could do here is we could order these using a number line. Okay, we don't have to, but we could. If I'm going to think about number line for like temperature, a good way to kind of think about it is like a thermometer. So you guys have seen thermometers like this where, it's, 0 degrees here and then it works its way up. I'm going to probably count by 2s here. So 2, 4, 6, 8, 10. We'll just go up to 10. 2, 4, 6, 8, 10. So this would be 2, 4, 6, 8, 10. And then going down would be our negatives. So -2, -4, -6, -8, and -10. So just like a thermometer, number lines can go up and down as well. They don't just have to go right and left. Okay, so if we look at our temps here, we'll order them. So we've got Monday's 5. So 5 on our number line would be between the 4 and the 6. Tuesday is -1. -1 would be in between 0 and -2. Wednesday is 8. Put a point at 8. Thursday is -3. So that would be between -2 and -4. Friday is 0. So point right on the 0. Saturday is -7. So that would be between -6 and -8. And then Sunday is -2. Okay, so they want us to order these from greatest to least. So if we're looking at the greatest number here, that would be our highest point on the number line. Or if we're looking at a right to left number line, it would be the furthest to the right. So in this case, that would be 8. Next one is 5. Then 0, -1, -2, -3, and -7. So 8 is the greatest and -7 is the least. Okay, next thing we've got to talk about here is absolute value. Okay, so what absolute value is it's your distance away from 0 on a number line. Okay, so you could write that down. Distance away from 0 on a number line. Okay, so if we're looking here at this picture, they kind of give a good example of what's going on here. So if I wanted the absolute value of -3, and we mark absolute value by basically tall straight up and down lines like that, and then whatever's inside of those, so like -3 in this case, that's what we're trying to find the absolute value of. So if I've got -3 on a number line, and I want to know how many spaces away from 0 that is, well, I know that's 3 spaces away, so my answer for that would be 3. Now, +3, this here, is also 3 spaces away. So if I did the absolute value of +3, I would also kick out a 3. Okay? And these are going to be represented as distances, so they should give you positive numbers. Okay, so let's look here at these ones. So for A, we've got absolute value of -1. Okay, so if you think about -1 on a number line, how many spaces away from 0 is that? Well, on a number line, -1 would be 1 space away from 0. So absolute value of -1 would be 1. Now for B, they give us 2 separate absolute values. So what you would do in a case like this is you figure out the absolute value of this one, figure out the absolute value of this one, and then we add those two together after that. Okay, so if I take the absolute value of 4, well, 4 is 4 spaces away from 0 on a number line. If I take the absolute value of -5 is 5 spaces away from 0 on a number line. And then what I want to do is I want to add those two numbers together. So if I do 4 plus 5, my answer would be 9 for that. Okay, now I'm going to throw a C in here to kind of show you the difference between some things. So I'm kind of going to do a different setup of these numbers here. So if I do absolute value of 4 plus a -5 like that, how this is different is these two are both inside this absolute value. So what I want to do is I want to solve for the inside part first and then take the absolute value of it. So I would want to solve here and do 4 plus -5, which would give me -1, and I still have my absolute value signs. Then I do the absolute value of that, so then my answer would end up being 1. Okay, so kind of see the difference there. These ones I do separately and then combine together because they're in separate absolute values. Here they're in the same absolute value, so I do that part first and then take the absolute value of whatever I got for that inside part. Okay, so tryouts on page 55, F through H on your own, and then I will check in and give you the answer to those. Okay, so for F, they got 9. For G, they got 8, and for H, they got 11. Okay? Alright, so that's all for this lesson. So your assignment is page 56, 18 to 48 even.